Let we go to the next topic, hydrolysis of salt of strong acid and strong base. So before we are going to this topic, we have to know the concept. Let me know the concept. We all know about acid and conjugate base and conjugate acid, right? So each and every acid will have their conjugate base, which means after removal of H plus ion, then the remaining negative ion is said to be the conjugate base of the acid. Like that base and conjugate acid, which means after the removal of OH minus ion in base, the remaining positive ion is said to be conjugate acid. So each and every acid will have their conjugate base and the base will have their conjugate acid. Have you understood? After the removal of H plus ions in the acid, the remaining negative ion is said to be conjugate base of an acid. And after the removal of OH minus ion, the remaining positive ion is said to be conjugate acid of the base. Now we are going for learning the concept. If the acid is strong, then the conjugate base is weak. If the acid is weak, then the conjugate base is strong. So opposite, if the acid is strong, then the conjugate base is weak. If the acid is weak, then the conjugate base is strong. Like the same in base, if the base is strong, then the conjugate acid is weak. If the base is weak, then the conjugate acid is strong. So this is the concept. And also we have one more concept. If the conjugate acid or a base is weak, then the conjugate acid or base does not react with water. During the salt hydrolysis, if the conjugate acid or base, whatever it is, if it is weak, it does not react with water. And the conjugate acid or base is strong, it reacts with water. Have you understood the concept? If the conjugate acid or base is weak, it does not react with water. If it is strong, it reacts with water. Now we are going to the topic, hydrolysis of salt of strong acid and strong base. So now we are taking the strong acid is HNO3, nitric acid, and the strong base is sodium hydroxide, NaOH. Strong acid example, nitric acid, and strong base example, sodium hydroxide. When acid base, as we told, this is a neutralization reaction. So when acid and base reacts, we will get salt and water. So by the removal of H2O, the remaining we are getting NaNO3 as a salt. So in this NaNO3, we have Na is a positive ion and NO3 is a negative ion, which means Na plus is the conjugate acid of a base. As we told that if you remove OH minus ion from the base, the remaining positive ion is said to be conjugate acid. Like that, NO3 minus is the conjugate base of the acid nitric acid. As I told, in the acid, if we remove H plus ion, the remaining negative ion is said to be the conjugate base of an acid, right? So when we remove H plus ion, the remaining nitrate ion is said to be the conjugate base, right? So in the salt, the positive ion is said to be the conjugate acid of the base and the remaining negative ion is said to be conjugate base of the acid, right? So we are going to the next step. So now we have the base is NaOH. So the conjugate acid of this base is Na plus, right? As I told before, base NaOH and the conjugate acid of this base is Na plus. We know very well that NaOH is a strong base So if the base is strong, then the conjugate acid will be weak. I told that concept opposite, right? If the base is strong, then the conjugate acid will be weak. If it is weak, it does not react with water. Have you understood? If the base is strong, then the conjugate acid is weak. If it is weak, it does not react with water. We'll go to the acid. So what acid we have taken? Acid is nitric acid, and the conjugate base of this nitric acid is nitrate ion, NO3 minus, right? As we know that acid is strong, then the conjugate base will be weaker, which means it does not react with water. Have you understood? So both conjugate acid and conjugate base both are weak, so it won't react with water. So no reverse reaction taking place. Have you understood? So no reverse reaction, no salt hydrolysis taking place in strong acid and strong base. So between the reaction of strong acid and strong base is an irreversible reaction. So the backward reaction is not possible. Backward reaction is said to be salt hydrolysis, right? So the backward reaction is not possible because both the conjugate acid and conjugate base are weak. If it is weak, it does not react with water, so it won't give their backward reaction. So in the formed Na plus and NO3 minus, both does not react with the water, which means water contains H plus ion and OH minus ion. So if does not react, what happened? There will be no change in the concentration of H plus ion and OH minus ion. So what they are telling, the concentration of H plus will be equal to the concentration of OH minus ion. So if their concentration is equal, we are telling that the solution is neutral. The resultant solution is neutral. So this is hydrolysis of salt of strong acid and strong base.